Okay, let's dive right into this explainer. Today, we're looking at a completely brilliant new format called BSON and how it can literally take our messy, chaotic digital data and organize it flawlessly. If you've ever dealt with modern databases, you know they can get incredibly cluttered, slow, and expensive. But a strict, self-describing, tabular data format built on JSON is totally changing the game. We're going to break down exactly how this works, and honestly, the best way to explain it is to use a concept we can all understand perfectly, like we're 5 years old again. So imagine walking into a playroom that is just completely covered and a chaotic pile of toys. You're looking for your one favorite action figure, and it takes forever, right? You're digging through blocks, you're tossing aside cars, tripping over stuffed animals. Well, this perfectly illustrates how traditional databases struggle with unorganized data. When applications need to fetch your information, say pulling up your profile and your recent orders, they're basically doing exactly that. They're digging through massive, disorganized piles of code, grabbing data piece by piece. It takes a ton of time, and it burns up a lot of computing power. Now think about the traditional way we store data, like standard JSON. In that world, every single piece of information is attached to a bulky text label. It's literally as if every single toy in that messy room had to wear a giant, heavy name tag that says red toy car or blue action figure. If you have a million toy cars, you're writing red toy car a million times. That's just massive, unnecessary data bloat. But BJSON? It does something so simple, yet so smart. It simply organizes everything into precise, pre-labeled compartments. You label the compartment exactly once, and then you just drop the toys into their proper slots. And that brings us to absolutely crucial concept here, positional integrity. Sounds fancy, but it just means this. If a toy is placed in compartment number 2, we automatically know exactly what it is without ever needing to read a label. So, if we decide the second compartment is always for the temperature reading, then whatever number we find in that specific slot is the temperature, period. By just trusting the position of the data, BJSON completely eliminates the need for all those repetitive, space-hogging name tags. But to make this toy box actually work, the format's creator, Elton Bonin, established a very strict framework. It requires exactly 6 mandatory top-level keys to ensure the whole system is perfectly self-describing. Every single Bijan file has to declare its format, the format version, the creator, the types of records inside, the fields, which is basically our master label for all the compartments, and finally, the values, which are the actual toys we're storing. Because the structure is so rigid and predictable, computers can parse it almost instantly. All right, let's jump to section 1, faster apps, less space. We're going to see how this brilliantly simple organization makes a massive difference in performance. Look at how a traditional, bulky update is instantly compressed into a tiny array of just 3 numbers. In the old way, you have to send the full text strings, sensor ID, and temperature every single time, say, a smart thermostat updates. But the be-adjacent way? It literally just sends the raw values to their exact pre-assigned positions. It acts as a micro-bandwidth positional delta sync. You're saving huge amounts of space because the logic is so beautifully simple. Just put the number in the pre-assigned slot and move on. And the real-world results of that simple shift? They're staggering. By dropping those repeated text labels, this positional sync drops network bandwidth costs by up to 80% for high-frequency IoT updates. Think about it. Millions of smart thermostats or gaming devices are constantly pinging a database all day long. Sending bulky text strings every time just clogs up the network. BJSON's positional arrays clear that traffic jam right up. And the financial impact of this is just wild. Utilizing this format in systems like Firebase Firestore reduces your database billing costs for complex entity fetching by up to 99.6%. Cloud databases typically charge you a fee for every single document you read. So if your app has to read hundreds of documents just to piece together one user's profile, that gets incredibly expensive, incredibly fast. Instead of paying for 251 costly trips to fetch a user, their 50 recent orders, and 200 associated items, a specific version called BJSON 104DB packages it all together perfectly. Your app only has to perform exactly one document read. Because the relational logic is built natively into the file format itself, your client app just grabs the whole toy box off the shelf in one fluid motion, rather than picking up 251 individual toys one by one. Moving on to section 2, built-in rules stop work. So how do we make sure the right toys actually go into the right compartments without forcing developers to do a ton of extra manual work? Well, normally developers have to write hundreds of lines of fragile, external rules to validate data.
They're basically building a separate system just to check if the data being saved is formatted correctly. Step 1, write data. Step 2, write rules. Step 3, pray they don't get out of sync. But bJSON uses its own internal fields array as an automatic security boundary. Think of a baby's shape sorter toy. The star block only goes in the star hole. The box itself is the security rule.
Literally, the documentation states that developers never have to write type-checking firebase rules again. The schema validates itself at the database ingress layer. The document is essentially telling the database exactly what its own shape sorter looks like before the data even enters the system. This saves engineering teams massive amounts of time and practically eliminates all those frustrating bugs caused by mismatched data types.
Let's head section 3, everything in one place. We're going to wrap up by exploring how you can actually store entirely different types of toys, like action figures and cars, in the exact same database without creating total chaos.
The bJSON family is actually broken down into 3 main formats to handle different situations. You've got version 104, which is for high-speed logs handling massive amounts of identical data. Then version 104a handles configurations, allowing primitive types and custom headers for file metadata. But the real star for complex applications, that's 104db. This is the version designed to manage complex, multi-entity relationships. Version 104db specifically acts as a multi-entity database. To keep things straight, it uses a required first field called the record_type_parent discriminator to ensure toys never ever get mixed up. If you're storing a user and an order in the same file, a user doesn't need a shipping address field in the exact same way an order does, right? So bJSON 104db simply places a null value wherever a specific field doesn't belong to that entity. It's essentially just leaving a compartment perfectly empty so the overall structure stays completely intact and mathematically predictable. So, considering the incredible gains in speed, the drastic 80 to 90% reductions in space, and the built-in shape sorter security that saves developers countless hours, ask yourself this. Look at your own application's data. If your data was a room, exactly how messy is it right now? Are you paying huge cloud bills just to dig through piles of repetitive name tags? Isn't it time to stop searching through all that clutter and finally build a better toy box?